Okay, so today I'm going to talk about some of the least known groups of primates. It's nonetheless a fairly important group, so I think it deserves a lot of attention. So we're going to look at it a bit today. So if I ask you to picture a primate in your head, you probably will come up with maybe chimpanzee. You'll come up with some monkeys, or maybe if you're Polish, the Poland's favorite proboscis monkey, king of memes. Maybe less common in the people's minds are lemurs, lorises, tarsiers. All these are primates, and when we think of primates, fundamentally, we're thinking of animals that have certain characteristics. And if we want to study the evolution of these animals, then we need to kind of like pinpoint exactly how we define this group. So primates, what they do have are some changes in the visual system relative to other mammals. They have grasping hands and feet, adaptations for leaping or jumping between branches, and low-crowned and broad teeth. So just to go through some of these in more detail, when it comes to the changes in the visual system, you have, first of all, really large eyes. And these eyes are put in the front of the face. This is not unique of primates. We see it happening in other animals like carnivores, etc. But it definitely happens in primates. And then there's a development of a bar of bone that you can actually feel it in just the side of your eyes. If you touch here, that bar of bone is called the postorbital bar. And primates are more visually driven animals, and they invest a lot more of their development and energy into the visual system than they do to olfaction. Primates also are characterized by having grasping hands and feet. So when that happens, for that to happen, what you need is to have an opposable thumb or an opposable big toe, and that allows you to do movement in two different directions and then grasp. And when that happens, what you get is, on one side of the finger, you get a nail. So it instead of claws, these structures get flattened, and then you get nails on one side, and then on the other side you get a fleshy pad that is very sensitive, and it's actually very good for precision grasping. Primates also have adaptations for leaping, and here you have the example of a tarsier, which is one of the most extreme cases of leaping, admittedly. But what you see in tarsiers is that if you want to jump from branches to branches, what you're going to need is a good, jumping system just right in your legs. So there's an elongation of the hind limbs, of the legs, and something that is quite spectacular in the tarsier is the elongation of these bones, or the tarsals, which is why the tarsier is named tarsier. These are your heel bones, but the heel bones in the tarsier are just like crazy long. And then you have also an elongation of the tibia and the femur. So all just generally they have these really long legs. So then the final broad definition of what is primitive for primates, and then defines the entire group, is that they have low-crowned and broad teeth. You can see here some molars, and you can see they're not very pointy. If you look at other types of mammals, you will see a lot taller teeth. So the crowns are quite short. If you were to look, for example, at a horse, the teeth are much, much taller. And then you also have broad molars. So the molars are the teeth at the back of your mouth. And if you look at basically the width of these molars are significantly broad. This is a specialization for fruit eating, which is something very characteristic of primates. Obviously, they eat a lot more things, but primitively, we are characterized for being fruit eaters specifically. So if you have all this together, and you put it together in your head and you want to study primate evolution, then you're like, okay, I got this. I go to the field, try to find some fossils, and if they have these characteristics, I could confidently place it in primates. And this is to some extent true. And you can do this exercise for a long period, a long range of the Cenozoic. So if we are up here, so that's present day, and this is the beginning of the Paleocene, that is when the non-avian dinosaurs went extinct. You can find primates of modern aspect, primates that look like today's primates, kind of up until the beginning of the Eocene. So that is 56 million years ago. And there are two major groups of primates at that time. One of them being adipoids, and the other one being omomyoids. There are more, but those are some of the most representative of the time. When it comes to these two groups, adipoids have generally been associated or more, that they have more characteristics that you can link them to lemurs and lorises of the present day, while the omomyoids are usually associated with tarsiers. So you can actually see quite striking differences, but the closer you get to the origin of primates in the Eocene, the more difficult it is to actually tell these two apart. So basically you can see here that they have a long snout, these have a short face and really big eyes. It's actually quite reminiscent of the tarsiers. And I actually just gratuitously, I just put a picture of Darwinius because it's Darwin Day, and this is an adipoid named after Darwin. So this has sparked a lot of controversy. I'm not going to get into this today. We can talk about it later if you want. But you can see that at that time, we actually get quite beautifully preserved skeletons. So we actually have a lot of evidence of what these animals looked like at that time. So when we see the appearance of adipoids and adipoids and omomyoids, what we see that just happened right before is this spike. Sorry, I'm just going to drive you through this. So basically, this is present day. And again, this is dinosaurs going extinct, non-avian dinosaurs specifically. And you have the Paleocene here, and then in the transition from the Paleocene to the Eocene, there was a huge spike of temperature, which is called the Paleocene-Eocene thermal maximum. This was actually quite extremely dramatic. It is the highest temperatures that you would see in the entire Cenozoic. So that drove a bunch of things to extinction, and then a lot of migrations happened as well, and different animals were just going from one continent to another. There was a lot of faunal exchange, and this was the opportunity for the earliest primates of modern aspect to finally arise and solidify the presence until the present day. But one might think, okay, so what comes earlier? So we see these two different groups, the adipoids and omomyoids. What happened between this PETM, or the Paleocene-Eocene thermal maximum, and the extinction of dinosaurs? So what do we have here? And what we have is Plesidaepiforms, which is a bit of a tongue twister. They could be named Bob or Bill, and it would be much easier, but sorry, Plesidaepiforms. Plesidaepiforms have been considered the first radiation of primates, and the debate over why they might be or not is what I'm going to talk about today. So the first Plesidaepiforms appear after the Cretaceous-Paleogene extinction event. That is the extinction event that wiped out the non-avian dinosaurs. And they were a fairly successful radiation of early primates. Excuse me, you have up to 11 families of Plesidaepiforms, with a bunch of different adaptations and so on. You find them exclusively, though, in the northern hemispheres. You don't find Plesiodepiforms in Africa, South America, or Oceania. This map, what basically is saying is that there are more people who study these kind of animals in North America and Western Europe. It doesn't really mean that that's exactly where they were, but we're getting more and more Plesiodepiforms from Asia, and actually my favorite one is that one here in Ellesmere Island in Canada, which actually have a slide. During the Eocene, Ellesmere Island was actually like not like you would expect Ellesmere Island or the Arctic to look like today. It was very swampy, but also it was not extremely hot. It would get to like 0 degrees in the coldest days. But you would have some hippos and some small mammals and some arboreal mammals. So actually quite a lush environment from what you would expect. And in this environment, you would see all these small little primates thriving. Probably this was used as a bridge for migration between North America and Europe. So the definition of Plesiodepiforms, or the definition of primates mainly, is challenged by the definition of Plesiodepiforms. The problem with Plesiodepiforms mainly is that they lack a lot of the characters that make primates primates. I was just telling you what makes a primate, and this defies that. So there has been a lot of discussion over are Plesiodepiforms primates or not. So we see that Plesiodepiforms are arboreal animals. That means that they are tree-dwelling, and as such, they have certain adaptations that allows them to locomote through the trees. And then they have teeth adapted to fruit eating. So this is one of the first tendencies that we see in the evolution of the lineage, where we start seeing the teeth all going, all the cusps and the crests all going down, blunter, more, curved. But when you look at the brain, these were not smart cookies. These were the dumb cousins of modern-day primates. Not very impressive brains. I'll show you a picture of that. They don't have forward-facing eyes like the primates today. Their eyes are on the sides, like many of the mammals today. And when it comes to modern primate-like grasping extremities, there's a yes and a no. Mostly it's a no. But then we actually have one case of a Plesiodepiform that has developed already a nail here. You can tell that this is a nail on the foot, not on the hand. The hands are actually, they have claws. But you can see that this is a claw-like fingertip, so basically the last bone, and how this one has already changed into a flattened type of end of fingertip bone to accommodate a nail. So we are already seeing some of the first attempts of looking a little bit like a modern-day primate. Also, they do have an opposable big toe in this case. And you can see the curvature of this toe is quite telling that it did a different movement with that, possibly associated with suspensory behaviors, kind of like just grasping branches to avoid falling, right? And here you have a beautiful reconstruction by Doug Boyer of this specific animal. It's the genus Carpolestes. And then, as I was saying, they don't have very impressive brains. When we think of primate brains, if you ask me, they're not that. They're just balls. They have developed such a big neocortex that the neocortex have basically expanded over everything. You can see so many things here. You have the olfactory bulbs, and you have exposure of the midbrain. You have so many things to look at. But that means that they don't have an expanded neocortex, and therefore the potential, like the cognitive potential is actually not that great. So these are two examples of plesiodepiforms where they could reconstruct the endocast. So basically that would be the closest to what we can get for a brain. And as you can see, they're just very, very well-preserved crania of these animals. So we do have a lot of good information on plesiodepiforms. So if they already have some questionable characters that would associate them to modern-day primates, not only that, they have particularly weird characters that make them not look like primates at all in some cases. One of them is this gigantic incisor, and this kind of is more reminiscent to the incisor of a rodent, for example, except that rodents have ever-growing incisors. These incisors don't, they just stay like that. They don't keep growing. But look at that. That is completely crazy. That's not what primate dentition looked like. And then there's massive dental reduction. So for this jaw, these are all the teeth that there are. So basically, the back of the teeth, then you have a huge gap, and then this giant incisor. So if you are not too familiar with plesiodepiforms, if you happen to find one for the first time, a living one, and you lived in the Pliocene, you would maybe confuse it by some sort of rodent. So that begs the question, what are plesiodepiforms related to, if they're so different from primates? So one of the two candidates that have been suggested are flying lemurs, and the other are primates. So I'll talk a little bit about flying lemurs. First of all, the name of flying lemurs is a complete lie. They are not lemurs. They do not fly. They actually glide. So whoever got the name, thumbs up. So the flying lemurs are also known as colugos, but I think flying lemurs is kind of like such an ironic name that I actually like overusing it. They live in Southeast Asia exclusively, and they are not very well diversified. We only have 2 species of them. And they also have a poor fossil record, which makes it very difficult to establish relationships. What does a very primitive flying lemur look like? What does a primitive primate look like? We don't know. So how can we tell if plesiodepiforms are in one way or another? So there's been a lot of studies trying to figure that out. Oh yes, no, I have some cute pictures of flying lemurs. So this is a baby flying lemur. And you can see, it's actually quite cool here, that the patagium, which is basically the skin that you have between the fingers and the extremities, they go in between the fingers, and kind of like, as you can see in this flying lemur just gliding in action, it goes all around it. It actually it's like a pentagon almost. And as I always say, that they're like very cute on one side, but completely the stuff of nightmares on the other side. And so that type of gliding is called mitten gliding, because it's like if you're wearing a mitten, like a glove with no fingers. So that is important because that has been one of the main points to associate plesiodepiforms with flying lemurs. And mitten gliders, what they have is a very elongated middle phalanx. So in our fingers, we have 3 phalanges, and the middle phalanx is the one that gets elongated in mitten gliders, or in this particular case, flying lemurs. So flying lemurs, these are the 2 species that you find, Galeopterus variegatus and Cynocephalus volans, and they don't have this postorbital bar that I was talking about just earlier, and they have relatively small brain, long snout, no forward-facing eyes, in many cases, they are quite regular mammal, generalized mammal, except they are very specialized for gliding, and the diet also is quite specific. So they are folivores. That means that they eat leaves. And to do that, they actually have developed really weird-looking incisors. And you can see that this is only one incisor. Then another one, then another one, and then another one. And so they have all these multi-cusped, multi-lobed incisors, making it almost like a hair comb. And they use these to scratch the surface of leaves, and that's how basically they eat. They also, if you were to open up, sadly, flying lemurs, you would see they have long intestines and a large cecum. So those are all adaptations for a diet that is difficult to digest. So basically leaves and plant material. So when Plesiodepiforms were suggested to be flying lemurs for the first time, they basically put forward the idea that they found basically some finger bones, so 1, 2, 3 phalanges, and the middle phalanx was very enlarged. So they were like, aha, we got this. This is a flying lemur. This animal must have been gliding. This type of phalanx proportions are only seen in flying lemurs. But these were phalanges that were not associated. These were phalanges that were found separately. So when very good associated skeletons of Plesiodepiforms were found, there was a little bit of a surprise. Here you have a quite excellent skeleton of Calicomes. This is a Plesiodepiform. And when you have an associated skeleton, then that's almost like a bingo moment. You can basically know exactly what touches what and what is next to what. So when we have all that information, there's also another good skeleton that was found of a semi-articulated Ignatius. So and you can see here you have some hand bones and finger bones. So when all that evidence was built, it was found that there was a mix-up of phalanges. This phalanx actually came from the foot, and this phalanx came from the hand. So they were incorrectly associated, and to be fair, it's actually really hard to tell apart foot and hand phalanxes. Not so much in humans, for example, they're extremely different. But when you get to these type of animals, it's actually quite difficult to tell them apart. Their hands can look like their feet. And when you have the proportions right, here you have a modern-day primate, a South American primate. Here you have a colugo, a flying lemur. So when you compare that, you can see that the proportions are much more similar to the ones of modern-day primates, primates that do some sort of grasping, some sort of clinging behaviors on trees, while the gliders really do have very, very elongated intermedial phalanges. So the meet and gliding hypothesis for Plesiodepiforms was basically hit pretty hard. And when you take into account all the evidence, morphological evidence that you get from the skeletons of Plesiodepiforms, the most comprehensive analysis, where they appear in the tree, is as a series of offshoots leading to modern-day primates. Here you have Thermopterans. Here you have another group that is closely related to us, the tree shrews. And then all the Plesiodepiforms appear more closely related to primates than they do to either Thermopterans or tree shrews. So that grants them the position of stem primates. which are basically like not true primates. They do not have all these characteristics that make them primates, but they're related to modern-day primates more closely than any other mammalian group today. So to make some final remarks, Pleistocene represent the first radiation of primates. They arose in the Paleocene and after the extinction of non-avian dinosaurs, and then the diversity declined by the Eocene. Probably this was due to the fact that they had to compete with the primates of modern aspect coming in the Eocene, as well as a huge diversification of rodents. And as you know, rodents are one of the most successful groups of mammals today. And that make them, if they have this privileged position, that make them pivotal for understanding the early evolution of primates and what basically means for a primate to be, what characters are primitive for primates and how you can then figure out, trends of character evolution. The relationships of primates to modern-day mammalian groups have been a matter of debate, making them question if they are primates or flying lemurs, but the most comprehensive phylogenetic analysis have supported these animals being more closely related to primates, but there's a lot more work to do. There might be some characters in Pleistocene that we see that they are more closely related to flying lemurs, as there are some indications that that might be the case of some of the families, but nonetheless, that makes them a key group at the very base of the tree that can help us figure out what is primitive. And in a more general answer, what is basically a primate in itself, right? They have the potential to define what it means to be primate. And with that, thank you for your attention. Dziękuję za uwagę. And thanks to the organizers and all of you for